It is my pleasure to introduce a friend, a mentor, a co-conspirator, not the inventor of MPLS, as some have alleged, but certainly a guilty party. Kireeti Kompella, it's great to have you. Welcome to the show.
Thank you, Scott. This has been a great event, and I've only had half a day. I will be here for another half day, but it's been really cool, and I love the response, the number of people who've come. Scott and Chris have done a great job. I should say the support team as well as the advisors have done a great job with the event, with the agenda, with the speaker lineup. Yeah, they picked me, so they're human, but we'll forgive them. So I'm going to talk about automation, right? I think that's why we're here. But here's a cool part of this. A lot of what I'm going to say is going to echo what I heard yesterday. So for me, that's really good because that's a validation. That's sort of what we're here for. I think we're here to share stories, support each other, come up with ideas, challenge each other, and move on to the next generation. So one of the things I'm not going to do is berate you for not doing enough automation. I think this is the wrong crowd. Yes, there is that aspect, but I'm not going to go there. So I almost never have this slide in my deck. So I will say this, that I'm going to refer to automation in Juniper and the automation journey we took. The reason is not because I want to sell you anything, because I don't actually make any commission on that, but because I think there are lessons you can take away from that. So just in case you start getting excited about some of the stuff that I'm going to say, especially in the later part of the deck, I want you guys to know, yeah, some of that might come out. When it'll come out, in what form it'll take, I don't know. So the idea here is to share some of the lessons that we've got in our automation journey that we've learned, and to share some of the things that could come. So that's my agenda. My math, as you can see, is terrible. The way I actually look at this is the plus sign is actually concatenation, and these are all binary digits. You guys know what I'm talking about, so that's how I interpret it, which basically means it's exponential, right? The more ones you have, you get to 2 to the n, right? So the first 3 are this journey and the lessons learned, and the next 3 are where we go from here. So again, I heard many things yesterday. My brain is way too small to remember anything. But someone talked about automation versus orchestration. A here is automation. I think the rest should have been orchestration. So I totally agree with that speaker. But sorry, I don't remember who it was. Thank you. Chris. So I'm totally on board with that, but I didn't have it for these slides, and I'm not going to change it now. So the first part is about sort of a straightforward automation application, if you want to call that. So think of, you're trying to solve a problem. So you think of a problem that you have, an operational problem, and say, okay, what data do I need to solve it? How should I process the data? And what is the action that I want to take when I see this happening? So I think you can encapsulate a lot of the basic automation stuff just using this. And that's hugely important. Doing that well, doing that in a general way is important. That's a starting step. But when you do that, that's what you get. That's all you get. So it is the starting point. I'm going to give you examples from driving. I'm going to ask you a question, and I'm going to ask you, please raise your hand whether it's true or not. How many of you have heard me talk about the self-driving network? Just raise your hand. No, kidding. Thank you. I'm going to give you examples from driving because that's just what I've been doing. So if you think about basic automation, you can think about just cruise control, right? The intent is I want to drive at 70 miles an hour. The process is look at the data is the speed, the current speed of the car, and the process is compare the current speed with the intent. And if it's higher, apply the brakes or ease off on the gas. If it's lower, apply the gas. So that's very simple. Another one is a little more complex, which is lane keep, or whatever your car manufacturer calls it, which is you determine where the lane markers are, and then you try to center your car in that. So fairly straightforward automation things that we have today. Most cars, modern cars have this. So the action is taken automatically, but the human, they say you should monitor the car, see what it's doing. With lane keep, for example, there are times when it can't actually determine where the lanes are. With cruise control, the old original cruise control, you can ram into the car in front of you if you're not careful. So you need to be sort of watching. So with a lot of the basic automation stuff, you have to be watchful as a human. What is my automation doing? So I'm going to give you some examples. I won't go through all of them, but here are some examples of some basic automation applications or automation ideas. So for example, your data is all the syslogs you're getting off your devices. You want to process them by deduplicating all the different syslog messages that you get, getting down to the essence of it, and then trying to determine what the root cause is. Or you can look at device telemetry and say, why is that device behaving differently from this other device? They should be in a similar situation. So you want to find hotspots and rectify anomalies. Or you look at bandwidth stats and say, how can I start predicting what the bandwidth will be in 6 months or a year so I can do maybe capacity planning or something. So you have others where you're looking at ingress traffic and trying to determine whether this is a DDoS attack, or you're looking at ingress stats and saying, is this a flash crowd or is this actually a DDoS attack? And in both cases, the automation will tell you what's going on, alert you to things, but the action is sometimes taken by the machine, sometimes by humans, usually by both. There are 3 more examples I'll give you that I'll actually follow up on a little bit more, which is if you have the topology of the network and you have your bandwidth matrix, then you can do traffic engineering. And based on that, you might want to place the traffic in a certain way or move traffic around to improve your traffic engineering. Or if you have not only the end-to-end bandwidth, but also the link bandwidth, you might identify congestion and say, I'm going to move this traffic around to alleviate the congestion. Or if you find optical errors or funky things going on at layer 1 with your links or the transponders, you might say, I'm going to move traffic to be somewhere else where that's not a problem. Again, the basic stuff, this is you get the data, you process it, and then the machine takes some action, the human takes action, sometimes both. So that's the starting point. But then you get to the next step, and then you say, OK, what if I have 2 apps? And what if they don't just work independently, but they start working together? Is there any value here? Is there any synergy? And that's what I mean by 1 + 1 = 3, that you have 2 apps, but you're getting this synergy, and you're getting a lot more out of your automation system than you would if you just run each app independently. So take 2 related problems, identify the data you need to do the work, process the data, but instead of taking independent actions, you actually take unified action. So I'll give you a couple of examples, again, from driving. You look at the speed, and you also find the lane markers. And then you say, I want to stay within the speed boundary because that's the intent, but I also want to stay within the lanes. In my car, which is not at all a fancy car, if I turn on cruise control, it does lane keep, which the first time I did that freaked me out. So yeah, I'm an automation guy, but yeah, trust but verify kind of guy. So But those two systems work together. Again, the action is automatic, but humans should monitor the car. Whoops. Oh, I did something foolish. Okay. Yeah. So I'll give you a simple example from traffic engineering, where you have a PCE controller, a path computation engine, that says, I know the topology, I know your bandwidth matrix, I know the current network state, I'm going to lay out the traffic in the network. If the topology changes, if a link goes down, for example, the link that's in red, if it goes down, I will learn of that, and I'll move traffic around so that nobody goes over that link. So yeah, this is straightforward traffic engineering. This slide and the next slide were taken from a colleague of mine. So the cool thing here is, in this case, that red link is either green, it's working, or red, as determined normally by IGP. It could be determined by BFD or something similar. But it's a binary thing. The link is on, the link is off. But if you actually have something that's monitoring link health and saying, this is the bit error rate, so hey, that's getting too high, or the packet drops are getting too high, there enough traffic flowing that my IGP hellos stay up, or my BFD echo requests get across and the replies come through. So from the IGP or BFD point of view, it's up, but it's not actually very healthy. So I can have those two working hand in hand and say, the health engine says that link is not healthy, and tells your traffic controller, move traffic away from that link. So then you might say, okay, I will reroute the link, reroute the LSPs to different paths. Again, you're not getting an indication from the IGP. You need this extra health application that tells you that the link is not healthy. So this is a 1 + 1 = 3. It's that synergy that gives you more out of. I have this health app that tells me what links in my network are healthy and maybe other things. I have this traffic engineering app, but I put them together, and it's actually really cool. So these are product names, ignore them. But the idea that we went through is, rather than selling these products as standalone entities, each doing its thing, traffic engineering or health monitoring, put them together, and actually you get more out of it. To do that, we had to change the product, in that they're not two standalone apps anymore. There's a common app or a common framework which has both of these functions. So that was the aha moment, at least aha moment number one. The next step beyond this was, yes, the individual apps are important. Yes, synergy is nice. But what if we go much further and we get to use cases? And this is, I think, where the comment yesterday about the distinction between automation and orchestration comes in. So take a set of related problems, and they're actually they're the basic things that you need to solve a use case. So you're no longer thinking of a problem by itself, but you're saying, here is a use case. And I'll give you a few examples of that in a couple of seconds. Identify the data that you need to solve all these problems, process the data, and then take that action, but it is a multi-step action, and so typically it will be run by a workflow. So from driving, you can think of, I have my not just basic cruise control, but what I think is called adaptive cruise control, where I'm not only trying to maintain the speed that was given to me, but I'm also measuring the distance to the car in front. I'm also trying to look at the lane markers and stay in my lane. So this, you can call this hands-free driving or call it whatever you want. But the point is, you've gone beyond just, I can keep a lane or I can manage my speed. You're now saying, you can take your hands off the wheel, except now the car monitors the human. And so this is the case, I believe, I don't have a Tesla, but I believe that if you take your hands actually off the steering wheel, it stops or does something. And there are other systems that actually look at your eyes and see where your attention is. And so, again, they will pull over to the side of the road or something. So you actually have the car monitoring the human, because what you have here is convenience, and humans, you give them a convenient thing and they overdo it. So you want them still paying attention. So this is actually, the fact that the car monitors the human rather than the other way around means that there's been a step jump here. So let me give you a couple of use cases from networking. We have this use case called assured onboarding, where it's not just zero-touch provisioning, but you actually say, I want to onboard a device. I want it to be, let's say I want it to be a PE, I want it to be a BNG, I might have, I want it to be a route reflector, or it might be a combination of things. So that's the kind of intent. Given that, you want to then say, is this device a genuine device from the manufacturer that I expect? Is it running the right version of software? Is it connected correctly to the adjacent devices? If I need to update the software, I do. I want to configure the device for the role that it has, and then verify that it's configured correctly. So I'm doing a whole bunch of steps, all to the end of I want to bring a new device into my network, but I want to do more than just configure it. I want to make sure that it is configured correctly. I want to make sure it is healthy and it continues staying healthy. So I want to do that ongoing monitoring. And I want to monitor the data plane to ensure that it's connected to whatever it needs to be connected in an appropriate manner. So this, again, you've gone beyond one use case. You've gone to multiple use cases, one application. You've gone to multiple applications to the end of bring a device into my network and make sure it is running correctly. I'll give you another example of transport network slicing. So the terms that you see, EMBB, MMTC, URLLC, basically these are terms from 5G network slicing, enhanced mobile broadband, machine-to-machine communication, and ultra-reliable low-latency communication. So that's kind of your intent. And what you want to do then is to convert that to the network view. So you want to configure your devices, and then from that, you're not done. You have to set up the probes to make sure that the experience that you actually have matches what the SLO, service level objectives, are. So are your service level objectives met? So if you think about what these device configurations are, topology filters, slice aggregates, paths, classful transport mapping, forwarding adjacencies, per hop behavior, bandwidth engineering. So you have a bunch of things you need to do in the network so that you have your network slice. And you can think of this as a compiler that says, here's the intent, this is the experience that's desired, fill in the blanks. So that is an example of a bigger use case where multiple things come together. So it's not automation, it is orchestration, but it is multiple things coming together for whatever the customer wants. This presentation, this is the second time I'm doing the presentation. I did it a month ago at a conference that Juniper held. It was at the Royal College of Surgeons in London. And the first keynote speaker was Dr. Sinha Khan. And he was talking about the use of technology in surgery. And for him, that use of technology was about convenience. So I took his slide and I changed a little bit, but I think it maps really well. So for example, he talked about unified communications, but I think in the network we talk about unified operations, optimized training, but we can also go beyond and do testing. Enhanced, well, for him, patient care, for us, enhanced experience for your end customer, scalability and adaptability, cost efficiency, again, for the end customer. So this idea that you think about things not from the point of view of the technology, because for him, for Dr. Khan, it's not about the technology, but it's about how do I put things together to be convenient for the patients, as well as for the doctors and the care staff. So for us, I think it's the same thing, that we should think about putting automation and orchestration together to be convenient for the end user and also for the networking, the NOC. So that was the past. That was our journey from individual apps that do cool things to apps working together to get that synergy, to a bunch of apps working together to give you use cases and talk about convenience. Where do we go from here? And I want to talk about holistic automation. I want to step away from this. And the reason for stepping away from this is it's important. I think these are all important steps. And you can then ask, where does 1 + 1 + 1 go? And so you can say, I want more apps. I want better apps with more features. I want better integration between the apps. Yeah, all great and all important, but this is incremental. How do I get fundamentally beyond this? And so that's where I think we should go, which is that fundamental evolution. Here are 3 paths, and there'll be more, and I think we will learn as we go along. But the first is AI ops. The second is a network digital twin, and the third is a CI/CD-like pipeline for automation. And yesterday, again, to echo people, somebody did talk about digital twin. Somebody did talk about, again, the person said very specifically, automation is not scripts. And when you do automation, you need a software discipline. So totally echoing that. For AI ops, I'm not going to talk a whole lot, but we will have a panel right after this. There are 3 avenues. One is a chatbot-type interaction with automation. So you ask Sir Alexa or whatever your favorite device is, your favorite chatbot is, tell me where there's a hotspot in my network, or where do I see anomalous behavior in my devices? And so it's not like something fundamental, but it is a lot easier for getting information from the network. The second is predictive maintenance. That's when you can predict that something's going to go wrong, and ideally even fix it before it even happens. So this is, again, stuff that is underway. People are working on this, and I think this is really cool. It gets you way beyond, oh, I need to fix that problem, like the golden 50 millisecond thing. It's like, yeah, before it even happened, I fixed it, or I bypassed it, or whatever. And the third is closed loop operation, and I think we use that term a little too loosely. So if you think about cruise control, it is closed loop operation in that you're measuring the speed, you're comparing that against the intent and saying go faster, go slower. I'm talking about way more sophisticated closed loop operation that has machine learning in the path, either supervised or unsupervised, so you can actually start taking actions, and humans can get further away from the network. I'm not going to talk much more about that. I'll go on to the other things. So here's this field, medical systems, that is really, really conservative. And Dr. Khan mentioned several times, very highly regulated, this especially in the UK. Very highly regulated, very conservative. And they're talking about digital twins. They're talking about mixed reality or augmented reality. They're talking about surgeons being able to visualize how to do the surgery based on an actual digital imprint from the patient before they actually go in there and start doing things. So if they do it, can't we? I mean, come on. So we have a product called Planner that pretty much mimics the topology of the network and some of the data plane stuff. But if you think of that on steroids, and think about not just the devices, but the software they're running, the topology, but the data plane, the control plane, the management plane, and how these all interact. You're now in a position where you have a platform for training people, so you can train them without putting them on the real network, and yet mimic what would happen in the real network. You can imagine exploring, like this doctor was here, exploring that particular thing that you want to do surgery on, but exploring that in your network using Vision Pro. I've sold my soul to Apple, but pick your favorite device. But imagine that you can explore your network using these headsets, mixed reality headsets, doing what happened analysis, like, okay, we had a meltdown in our network yesterday. What was the cause? Or what if scenarios? What could happen if I made this change? What would happen? So I think these are things that are now well within our grasp, and we can easily get to the point where we can put this in the network. We can start at least doing things like the training and the mixed reality visualization. But we are getting to where we can do this what happened analysis. So, and sort of a slider saying, what are the events that happened in the past 24 hours, or what are the events that happened in the past month? CI/CD pipeline, again, if you're serious about doing automation and you're serious about thinking of it in a much more structured fashion, it's not just a script that you throw out there and then throw it over the wall in one of the slides yesterday, and then hope the NetOps people pick it up and run with it. You need this. You need to be able to say, this is code. I'm able to snapshot it. I'm able to version it. I'm able to say, does it really work? You commit it. You run the tests. Think Git pipeline. And if it breaks, you roll back. If it works, you deploy it to your network. So that level of discipline, that ability to do things and test them before you put them in the network is huge, because that means you can stop being so conservative about what you're going to put in the network. You can try things out. If you have a good digital twin that replicates the behavior in your real network, you can have a lot more confidence in trying out new services, trying out new automation techniques, trying out maybe new machine learning techniques, and not fret that this will destroy my network. There was a line yesterday about automation will destroy my network faster. You do this, maybe not. So that brings me to my essentially final point, which is, what is the holy grail for network automation? I talked 8 years ago, almost to the day, on this idea of a self-driving network. For those of you who want a little bit of, tongue-in-cheek variation of this, I like the term self-driving network because I hate the term software-defined networks. It's like, what the? What is not software-defined? I can tell you, being at Juniper way early, we started writing the software well before we had a box. I mean, it's just, so SDN, if anyone asks you what SDN is, just tell them self-driving networks. That's the answer. But at the time, 8 years ago, a lot of the terms that I used then are terms that now are in common parlance, which is great. Again, it's a validation. But at the time, it looked like science fiction. The idea of putting AI techniques and machine learning in networks, supervised or unsupervised learning, all of this stuff, like, yeah, well, I don't know what you're talking about. Today, we're really close. I think we've learned a lot. Streaming telemetry was another thing that was not in common parlance back then. But it was clear that you can't just poll once in a while. You can't use SNMP for all this stuff. You want lots of data and you want it fast. How am I doing, Scott? If you want lots of data, you want it fast, you want it accurate, garbage in, garbage out. So you want good data and you want it timely and accurate. You need streaming telemetry. So we've come a long way, and I think that's great. I think there's still a ways to go. And I think there's lessons from self-driving cars that we're promised one, especially a certain, what do they call them, space? What was the term? Space Karen. A certain person would keep telling us that, yeah, next month or next year, you'll have a self-driving car. Not happening so fast. I think the really cool thing about aiming for something like self-driving is that you you push yourself a lot harder, you get a lot further if you have that kind of vision. But you really want a system that will do a lot of the work, then come back to you and say, is this what you would do in my place? So it gives you advice, it gives you recommendations, it crunches a lot of data and says, here are the things that you should look at, but it doesn't actually necessarily have to do everything. So you don't need full self-driving right away, but you want to be on that path because that will push you to do more with your data, with your automation, with your machine learning techniques. So it's time to step back and ask what comes next. And I think some of the things that I talked about in the previous slides and that people have talked about here about making sure that your process is really rock solid and making sure that you look at these new technologies like digital twins and virtual reality or augmented reality and bring that to making your network automation task easier. So that's, I think, from the point of view of what I wanted to tell you. But I think the last message is automation is nothing if you don't use it. So you have to make it your own. And there was someone who said something similar yesterday. What is your vision of automation? What do you want automation to do in your network? And again, automation, orchestration. I haven't been very careful with my use of words. But you need to ask yourself, and a lot of people say, oh, it's to reduce the number of people in the ops group. I think that's a very short-sighted view of things. There is the problem that, and again, this was talked about yesterday, do you want to hire a networking guy and teach him software or her software, or do you want to hire a software engineer and teach them network automation? There is no good answer. You need this combination of skills. It's hard to hire people, especially in the bigger telcos. I think even in the big, the mega data centers, the hyperscalers, it's getting hard. So you need to ask yourself, and your higher-ups need to ask themselves, what is it that we want from automation? How do we put this in our network? And what is it that will drive this into actual adoption, into actual use? So that's the last thing I want to leave you with. And don't ask me any questions because I don't have any answers. 5 minutes for questions. This is a common response. And I draw one of two conclusions. I was just is there someone there? Yeah.
Yep. Hi, Jacob Young. I'm curious, what machine learning techniques you've experimented with, even in a lab situation. I'm just looking for ideas about what to do, with our terabytes of telemetry data and things like that. So, thank you.
Yeah, thanks. Good question. So the most common use of machine learning techniques are, it's not even necessarily machine learning, statistical analysis that will tell you anomalies. So if I've got 20 boxes deployed in very similar situations, but one box is running at 75 degrees Celsius or 95 degrees Celsius, and the other boxes are running at 70 degrees Celsius, you might want to ask yourself, why is that happening? And is that something in the box? Is that the fan speed? Is that air conditioning? So that's one common use. It's not machine learning per se. It's more like just statistical analysis. Another one that we're really working on in Juniper is predicting bandwidths. So if you guys know what auto bandwidth is, you basically say, here's my LSP. I want it to be a 1 gig LSP, but I know 1 gig is not going to cover all situations. So measure the actual bandwidth coming into the LSP, and then upgrade it to 2 gig if there's more traffic coming in, and drop it back to 1 gig if there's less traffic. The problem is it's a lagging thing, and between the actual increase in the bandwidth and the change in the reservation, is such a big lag that it actually doesn't work well. So we've used machine learning techniques to do this, and we have 3 or 4 techniques to predict bandwidths and change the bandwidth, the reservation on the LSP based on that. and it works a lot better than actually waiting for the bandwidth to ramp up. So those are two simple techniques. The other thing that people have used is machine learning for detecting whether traffic is bad or good. So you want to know whether it's a DDoS attack. So more on the security side, where you want to be able to filter out or block traffic. So those are common things. But I want to get to the place where I can predict when a transponder will fail by looking at the power signature or looking at the bit error rate or various properties and say, oh yeah, that's going to go out. I don't have to put transponders in every CO and every POP if I can do that, because then if I get a 24-hour, 48-hour notice that these transponders are going to go out, then I can get them shipped there in time and replace them before it actually happens. So these are all very tangible things that we could do in the near term. I think there's a lot more things. For example, predicting your customers' usage of the service you give them. So whether you give them an internet service or a VPN service and saying, oh, this is how they're using it, so I'm going to adjust how I've provisioned it so that they get a better experience, but I maybe use less resources in my network. So again, it gets a bit creepy, but anything with AI gets creepy. Yeah, one more question? And just shout out if you're there. I think we're good. Okay, thank you, everyone.